Hey there, health enthusiasts! Welcome to another insightful journey into the world of human biology. Have you ever wondered what happens to your body when you don't drink enough water? Whether you're working out, enjoying a night out, or just going about your day, staying hydrated is crucial for your health. Dehydration occurs when your body loses more fluids than it takes in. This can happen easily during exercise, especially if you're sweating a lot and not replenishing those lost fluids. Alcohol consumption can also lead to dehydration. Alcohol is a diuretic, which means it makes you urinate more, causing your body to lose more water than usual. Even your diet can play a role. Eating salty foods can make you feel thirsty and lead to dehydration if you don't drink enough water to balance it out. The effects of dehydration can range from mild to severe. You might experience symptoms like dry mouth, dizziness, and headaches. In extreme cases, dehydration can lead to serious health issues like kidney stones or heat stroke. The good news is that preventing dehydration is simple. Just make sure to drink plenty of water throughout the day, especially if you're active or consuming alcohol. So next time you're out for a run, enjoying a night out, or just snacking on some chips, remember to keep that water bottle handy. Staying hydrated is key to keeping your body functioning at its best. Cheers to good health. Now before we get to the magic trick, let's talk about what dehydration actually means. Just like you and I get thirsty, alcohols can lose water molecules, H2O, under the right conditions. This happens when we add some heat and a dash of acid, like a squeeze of lemon juice on a hot summer day. The acid helps to speed up the process, making the alcohol molecule eager to give up its water molecule. Now, here's where things get really interesting. In the world of chemistry, small changes can lead to big differences. Take alcohol molecules, for example. They might seem simple at first glance, but they have a fascinating trick up their sleeves. When an alcohol molecule loses water, it forms a double bond, like two friends holding hands. This process is called dehydration, and it's a key reaction in organic chemistry. But the story doesn't end there. But sometimes there are multiple places where this double bond could form. Imagine a dance floor where different pairs of friends can hold hands in various spots. The molecule has to choose where to form the double bond. How does the molecule decide? It's not random. There's a method to the madness. The molecule follows certain rules to determine the most stable and favorable position for the double bond. That's where Zaitsev's rule comes in. This rule, named after the Russian chemist Alexander Zaitsev, provides a guideline for predicting the outcome of the reaction. According to Zaitsev's rule, the more substituted alkene, the one with more carbon friends attached to the double bond, is usually the one that forms. This handy rule, named after a clever Russian chemist, tells us that the more substituted alkene, the one with more carbon friends attached to the double bond, is usually the one that forms. This is because the more substituted alkene is generally more stable due to the electron donating effects of the additional carbon atoms. More friends, more fun, right? In the molecular world, having more carbon friends makes the molecule more stable and happy. So next time you think about chemical reactions, remember that sometimes the more the merrier. Section 4. Dehydration Decoded. A step-by-step guide. Let's break down the dehydration process step by step. First, the acid gives a little push to the alcohol molecule, making it easier for the water molecule to leave. This creates a positively charged carbon atom, kind of like a lonely dancer looking for a partner. Then, a neighboring carbon atom, feeling generous, shares its hydrogen atom with the lonely carbon, forming the double bond. Voila! We have an alkene. Section 5. Why Zaitsev usually wins, but not always. So why does Zaitsev's rule usually work? Well, it all comes down to stability. The more substituted alkene, with its posse of carbon friends, is like a popular kid in school. Everyone wants to be around it, making it more stable. This stability makes it the preferred product of the reaction. It's like choosing the sturdiest chair in the room. It just makes sense. Section 6. Exceptions to the rule when less is more. But hold on. Just like in life, there are always exceptions to the rule. In the world of chemistry, these exceptions can be just as fascinating as the rules themselves. Imagine you're in a lab, expecting a certain outcome based on all the principles you've learned. You've followed the steps meticulously, but then something unexpected happens. This is where the magic of chemistry truly shines. Sometimes factors like the shape of the molecule or the type of acid used can influence which alkene forms. The geometry of the molecules can play a crucial role, leading to results that defy initial expectations. For instance, steric hindrance might prevent the formation of the more substituted alkene, favoring the less substituted one instead. In some cases, the less substituted alkene might actually be the major product. This can be due to a variety of reasons, such as the stability of the transition state or the specific conditions under which the reaction is carried out. It's a reminder that chemistry is not always black and white. There are shades of gray that make it endlessly intriguing. It's like a surprise twist in a movie. You think you know what's going to happen, but then, bam! Something unexpected occurs. These moments of surprise are what keep scientists on their toes, constantly questioning and exploring. They remind us that the journey of discovery is filled with unexpected turns, making the field of chemistry both challenging and exhilarating. Section 7. Dehydration, small molecules, big impact. That's dehydration of alcohols in a nutshell. It's a simple reaction with big implications, allowing us to create a wide range of important molecules. From plastics and perfumes to medicines and materials, the possibilities are endless. So next time you see a plastic water bottle or smell a fragrant flower, remember the amazing chemistry of dehydration and Zaitsev's rule at work. Keep those science brains buzzing, everyone.